Welcome to our full syllabus channel. Today I am going to discuss about the phase equilibrium. But before we are going to discuss about the phase equilibrium, I want to discuss something about the equilibrium. This equilibrium is actually divided into the three parts, that is the chemical equilibrium, ionic equilibrium and phase equilibrium. Today I am going to discuss about the phase equilibrium, but before that I want to tell you about something about the chemical, ionic and phase equilibrium. What is the chemical equilibrium? It is simply used for the strong electrolyte. Strong electrolyte means the ions which is there any chemical compound which is easily dissociate into the ions is known as the strong electrolyte. Okay? And you will discuss this. You will study this strong electrolyte in the chemical equilibrium, weak electrolyte in the ionic equilibrium, and moderate electrolyte simply which cannot be dissociate easily into the ions. You will study these things in the phase equilibrium, and today I am going to discuss about this phase equilibrium where we use moderate electrolyte. Clear guys? Now what is this phase equilibrium? Simply this is the F is equal to C minus P plus 2. This is the formula of phase equilibrium, and I am going to discuss one by one what is F, what is C, what is P, and what denotes this 2. Okay, now don't be confused here with the state of matter and the phase. State of matter is like solid, liquid, gas. You can easily distinguish then solid, liquid, gas by their physical appearance. Like you know what is solid, what is liquid, what is gas. But here I am going to discuss about the phase equilibrium, and this phase is mainly of two types. One is the homogeneous phase and the second one is the heterogeneous phase. What is homogeneous phase and heterogeneous phase? First I am discussing here about the phase. Now homogeneous phase and heterogeneous phase. Homogeneous phase is physically not separate from each other. Like you have a salt and water. If you dissolve this salt into the water, can you distinguish where is the salt, where is the water? No, because there is no any physically separate things there. You cannot distinguish between where is the salt, where is the water, because they are soluble to each other. This is known as the homogeneous phase. What about the heterogeneous phase? Because here physically no separation, but in heterogeneous phase they are separated by the real boundary or imaginary boundary. It is very important guys, they are separated by the real boundary, imaginary boundary. This is the heterogeneous. Hetero means you can say different, and homo means same. Okay, what is this real boundary and imaginary boundary? Suppose you have a container which is separated by a wall and oil and water. In the one part of this container you have oil, in the another part of this container you have water, and you know these things, oil and water are not miscible to each other. Okay, then it means there is the real boundary, they are separable to each other, they have a physical boundary. Now imaginary boundary, like you have a container, there is no any separate wall, then if you mix water and oil, then you know water and oil not mixed to each other, then the above liquid will be the oil and the below one liquid is the water. This is the imaginary boundary. You can easily imagine because they are not miscible to each other, so there is the imaginary boundary. So you can say heterogeneous phase either real boundary or imaginary boundary, but you can easily distinguish between these two, that is the heterogeneous phase. So in the phase equilibrium we are going to discuss about the moderate electrolyte. Here I have discussed already, and the second thing we are going to discuss about the heterogeneous phase. Guys, it is very important, it only works for the heterogeneous solution, a heterogeneous phase. Okay, we can't study these things in the homogeneous phase, and this is the real drawback of this phase equilibrium. We can only study about the heterogeneous phase, and that heterogeneous phase you can easily say it is separated by a real boundary or imaginary boundary, but it can be easily separatable, that is they have the different phase. Okay, now how to determine the phase? It is very important, like I have discussed here. You have to calculate how to determine F, how to determine C, how to determine P. Okay, and I will discuss one by one what is F, C, P, but here first I am going to discuss about the P. Here how to determine phase. Like the first one is the gas. All gases are miscible to each other irrespective of number. Guys, it is very important, all gases are miscible to each other irrespective of number. Suppose you have 4 or 5 different type of gases like HCl. Guys, don't be confused. HCl is a gas. HCl, SO2, methane, ethane, they all are gas. If you mix to each other, you can't be distinguished between them. That is the methane, that one is ethane, that one is the propane, because they are easily mixed to each other. So whatever the number of the gas, different number of the gas, phase will be 1. Whatever the number of the gas, either 10 gas, 20 gas, 30 gas, phase will be always 1, because they are easily miscible to each other. There is one condition when the gas are not miscible to each other. We will discuss it later, but here whatever the number of the gas, they are easily miscible to each other, then the phase will be 1. Now in the liquid, you know, in the case of liquid, if it is immiscible, what do you mean by immiscible? It means they are not mixed to each other. Then number of liquid is equal to number of phase. If liquid is immiscible, like example, like here, oil and water, they are not miscible to each other, then number of liquid is equal to number of phase. How many number of liquid is there? Oil is one liquid, water is there another liquid, then there is 2 liquid, then phase will be 2. Oil and ethanol means alcohol, it is also not miscible to each other, then phase will be 2. So in case of what you have studied yet, in the case of gas, there will be only one phase. In the case of liquid, if it is immiscible, then number of liquid is equal to number of phase. And if liquid is miscible, like liquid mix with each other, then phase will be 1. Like water and milk. Yeah, you can easily say water and ethanol, they are mixed to each other. If they mix to each other, then phase will be 1. Now solid, how can we determine phase in the solid? Solids are separate entity, yeah, you can say separate species, yeah, separate compound, separate element. They are not mixed to each other, you know it very well. Like you can't mix platinum, silver, gold, iron to each other. Okay, so number of solid is equal to number of phase. Guys, it is again very important, number of solid is equal to number of phase. Like here you have platinum, gold, silver and iron. There are 4 different type of solid, then phase will be 4. Okay, so I am going to discuss it one by one, but before what I am going to summarize this. In the gas, whatever the number of gas, phase will be 1. In the case of liquid, if liquid are immiscible, then number of liquid is equal to number of phase. If liquid is miscible, then phase will be 1. And in case of solid, number of solid is equal to number of phase. Whatever the number it is, number of solid is equal to number of phase. Now one very important things here, this is very important. If solution is given in either liquid or solid, it is guys very important. If solution is given, solution term is given in either liquid or solid, then phase will be 1. Solution, it means they are easily miscible to each other, they dissolve in each other. It means you cannot distinguish between them. Then whatever it is, liquid or solid, if solution is mentioned there, then phase will be 1. Like solution of silver and gold, like a solution of silver, again you can easily say solution of silver and gold means we have first melted the silver at their melting point and melted the gold in their melting point, and we can now mix each other, because in the melt, if you melt this, they are in the liquid form. If you melt this, they will be also in liquid form. Then you can easily mix to each other. It means solution, if solution is given, whatever it is, liquid or solid, the phase will be 1. Okay, solution of salt in water, again salt is solid, water is liquid, but phase will be, because it is solution, then phase will be 1. So I hope you can easily determine whatever the phase asked to you, you can easily determine what will be the phase of the given solution. Okay, now here I am going to discuss some phase here, and in front of you I am going to tell you whatever the phase will be. Now only solid is given, then phase will be 1. Okay, H2O solid. What do you mean by H2O solid? It means it is ice. Okay, ice. So you can easily say H2O is solid means ice, phase will be 1. Here liquid, again only one phase. Now here solid and liquid, okay, they are in equilibrium. You cannot say ki this H2O is dissolving. They are in equilibrium. Here is solid, here is liquid. Again the phase will be 2 because one is solid, one is liquid, and here it is not mentioned their solution or anything else. Then phase will be 2. Now solid, liquid, gas. Solid is different phase, liquid is different phase, and gas is different phase. Then phase will be 3. Oil in water, they are the liquid but not miscible to each other. The number of liquid is equal to number of phase. Then phase will be 2. Oil in ethanol, I have already mentioned, phase will be 2. Now ethanol and water, you know it very well. Ethanol and water, it means phase will be, because they are miscible to each other, then phase will be 1. Again ethanol, water and oil. Okay, ethanol and water can easily mix to each other. Okay, then it will form, ethanol and water form one phase plus oil. Ethanol and water have one phase and oil has different phase. It means this form one phase and this form another phase. Then phase will be 2 because they are miscible to each other. Okay, now NaCl water can be easily dissolved. Then phase will be 1. Here is not equilibrium, here is the plus. The NaCl can be easily dissolved in the water. Then phase will be, and it will form solution. Now here silver solid plus H2O. If it not mentioned here whether it is solid, liquid, gas, then you can easily assume if it not mentioned, then H2O will be always in the form of liquid. Then here is the solid, here is the liquid, and silver will never dissolve in water. Then phase will be 2. Again, now this is very important. A solution of A liquid, B liquid, C liquid, whatever the A, B, C, doesn't matter. A solution of, if it is solution, then either liquid or gas, phase will be 1. Again a solution of, again guys, whatever the liquid or solid, if it is mentioned here solution of A, B and C, they are solid, then phase will be 1. Here it is not mentioned here solution not mentioned here, solid, liquid, gas. What I have told you, if there is solid, then number of solid is equal to number of phase. Here is 3 different solid, then phase will be 3. Now here 1, 2, 3, 4, 4 gas, 1, 2, 3, 1 liquid, 2 solid. See, whatever the number of gas, phase will be 1. So this contains 1 phase, plus here 1 liquid, another phase, plus what I have said, number of solid is equal to number of phase. Here is 2 solid, then there is 2 phase. That means 2, 1, 4, 2, 3, 4. Total number of phase is 4. And don't be confused or don't be scared about these things. They're very simple. Okay, now here is the gas, 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 gas. Whatever is the number, phase will be 1. Again here gas, liquid, solid, they are totally different from each other. Phase will be 3. Again the last one, gas, ethanol, water, solid. Guys, they can be easily mixed to each other and both are liquid, then phase will be 1. Here solid, phase will be 1. Here gas, phase will be 1. Then total 3 phase. Okay, so you can easily determine in the given questions, you can easily determine what will be the phase. Okay, I'm again going to summarize these things. Whatever the number of gas, phase will be 1. If in the case of liquid, if they are miscible, then phase will be 1. If they are immiscible, number of liquid is equal to number of phase. In the case of solid, the number of solid is equal to number of phase. If suppose 5 solid is given, then number will be 5. Phase will be 5. And if solution is mentioned either in the phase, either in the liquid or solid, then phase will be 1. Okay, now Now second thing, what I have mentioned in the phase, f is equal to c minus p plus 2. Now what I have discussed yet, I have discussed about the phase. Now in this section I am going to discuss about the component. Okay, now how you determine the component. What is component? The definition is minimum number of independent variable constituent by which composition of each phase can be expressed in form of chemical equation. Guys, मुझे तो बिल्कुल समझ नहीं है what they want to say. चलो, I'm going to explain is what is this component. Okay, suppose like you have this equation, H2O solid, H2O liquid, and H2O gas. If it is solid, it means I am talking about the ice. This was simply water, and this is simply water vapor because H2O is in the form of gas. Now if I would ask to what will be the phase? The phase will be, this one is the solid, liquid, gas. They have totally different phase. Then phase will be 3. Now what I am going to ask you, what is the component? Now what is the component? See, component is the simply a chemical species or chemical compound. They are all chemical compound. A minimum number of chemical compound. Again, a minimum number of chemical compound. Minimum number means minimum. 1, 2, 3 doesn't matter. It should be minimum to justify all these 3 phases. Like if I'm taking any of these 3 and they can explain both 3 phases. Okay, like what I'm saying, like I have taken H2O as a component, like H2O I have taken as a chemical compound. This H2O, and we have 3 phases: H2O liquid, H2O gas, H2O solid. Phase will be 3. What he is saying, minimum number of chemical compound which can explain all the phase. Like this H2O, this phase liquid is also made up of what? H2O. This gas is also made up of H2O. This solid is also made up of H2O. So this is the minimum. So what will be the component? Component is the 1. One chemical compound can explain all the 3 phases. This is the simply component is the minimum number of chemical compound which can explain all the given phase. Here is the water. Yes, you can say simply the component number is 1 which can explain all the 3 given phase. This is your component. Now simply if anyone can say write the definition of component, then you can easily copy and paste these things, but I'm not going to explain these things. Like here, if here is the equation, A will form B, A will form C, and there is no relationship between B and C, then you can say there will be at least 2 components you require to express all these 3 phrases. Here A is made up of B, A is like B is made up from A, C is made up from A, and also C produce B. It means these 3 are interconnected to each other. Then component will be 1, because if you take any one, they can easily make all these things. But here component will be 2. Now how to calculate the component? Here is the formula given to you. Okay. But what component is simple minimum number of chemical compound which can explain all the given phase. Okay guys, I'm going to write it here. It is very important, minimum, and very very simple form. Minimum number of chemical species या compound which can explain all the given phase. Simple. Okay, now how to determine or how to calculate the component? Here formula is C is equal to N minus E. N is the number of chemical species, number of chemical compound. Now this is the different thing what I have what I have tell to you. Now this is the C is equal to N minus E. N is the number of chemical species and E is the number of equation. How to calculate this component? We can calculate this component by this formula. Now there is some condition for this formula. If ions is given to you and this ion can form a neutral compound, like suppose Na plus Cl is given to you, okay, so you know very well that NaCl can form a neutral compound. So if Na plus and Al plus given to you, they are also ions, but what they form any compound? No. It means if ions is given to you and they form a neutral compound like NaCl, then you have to take E as a 1. Clear, guys? If equilibrium is given to you, then you will take E as a 1. Like here, H2O equilibrium with H2O. This is liquid, this one is solid. It means there is equilibrium given, then you will take E as a 1. Okay. There is also some conditions, like I will tell you later, like Pa is equal to Pb, then you will also take this one is equal to E is equal to 1, and if reaction is given, then you will also take E is equal to 1. So N is the number of chemical species and E is the equation, and what the equations are I have told you here. If ions plus neutral 1, equilibrium 1, condition given 1, I will discuss it later, and if reaction is given you will take 1. Now here H2O, how many chemical compound is there? 2. Don't be confused, guys, this is also H2O, this is also H2O, don't be confused. Now I'm saying just count the number 2. Then formula is C is equal to N minus E. Okay, N is the number of chemical species, chemical compound. Number is means this one and this one, 2 number, then N is equal to 2. And what is this E? What I have said, here is no ions, here is what? Equilibrium. For the equilibrium you will take E is equal to 1, then 2 minus E. Here is the equilibrium given, 2 minus E is equal to what? 1. The component of this one is 1. Again H2O liquid is given, don't be think too much, there is only 1, nothing is there. Now H2O, see H2O solid, H2O liquid, H2O gas. Now think about it. Here is 3 chemical species, okay, and how many equilibrium is there? 2. 1 equilibrium here, 1 equilibrium is here, so you will take E as 2, the component will be 1. Now CaCO3, this one is the solid, CaO solid, CO2 gas. What will be the phase? Think what will be the phase. If I'm asking about this phase, then we will discuss about the component. Phase width, this one is solid, this one is solid. If there is 2 different solid, it means they have 2 phase plus 1 CO2 is gas, then phase will be 3. 2 different solid and 1 gas, 1, 2 and 3 phase, then phase will be 3. Now how to calculate this C and E? Now number of chemical species is 3, 1, 2, 3, then you have 3, and equilibrium is 1, then component will be 2. NH4Cl, again this NH4Cl is solid. When it will decompose, it will form NH3 ammonia gas plus HCl gas. Here C is equal to N minus C, chemical species is 3, equilibrium is 1 is equal to 2. But now the condition is but if both products are gas, both or any of the product is, if all are the gas, okay, then the condition will be, if they are the gas, the condition will be PNS3, pressure of NS3 is equal to pressure of HCl. If the product will be, all product will be gas, here the product will be gas, then P is equal to NS3 and pressure is equal to HCl, then C is equal to N minus E. Now here is the condition what I have said. Yeah, for the A, the condition is P is equal to A P B, then you will take E also as 1. So I'm going to discuss it here now. If all the product is in the form of gas here, if all the product is in the form of gas, then you have to already you have to taken it whether it is given or not. P is equal to NS3 is equal to SCl, then C is equal to N minus C, and is equal to number of chemical species here, it is 1 2 3, you have taken 3. Now what about this 2? This one is the one is from this one and another is from the equilibrium. Okay, then E will be 2, then 3 minus 2 is equal to 1. This is, guys, very important. Okay, now if again same thing, if same question like the above one, NH4Cl, again NH3 gas and HCl is gas, again given, but what given in presence of other gas? In the equation it is given like in presence of other gas. What does it mean? Like now P NH3 is equal to not is equal to P HCl. This pressure of NH3 is not equal to pressure of HCl. If it is mentioned in your equation, yeah, in your question, then N minus C, 3 chemical species you have only considered for the equilibrium only, then component will be 2. If it is not mentioned there, then you have to take 2, one for the equilibrium, one for this pressure equilibrium. Okay, this equilibrium and this pressure equilibrium when the product is gas. If it is not mentioned, then you have always take only the equilibrium, then component will be 2. This question asked several times in your exams. So guys, it is very important. Please read it very carefully. Now, aqueous solution of NaCl. Simply, guys, aqueous solution of, if NaCl is given, then component will be, again I'm saying, if there is aqueous solution is given, then component will be also 1, phase will be also 1. It means they are dissolved, you cannot separate them because there is the solution. Then phase will be 1, component will be 1. Okay, now NaCl H2O. Here is no equilibrium, but you know there is the ions and they can be neutralized. Then C is equal to N minus E. Component is 3. Equation is only for the neutral. Minus 1 is equal to 2. Then component will be 2. Now this one is given in your question. It is also very important. NH4Cl, NH4 plus Cl minus S2O. Okay, now what will be the component? See, guys, here Na plus is given, Cl is given. You know it, when Na plus Cl will combine, they will form NaCl. Clear? But here NaCl is not mentioned here. You have only given Na plus Cl minus. Now see here, NH4 plus Cl minus, and you know it, when this will combine, they will form NH4Cl H2. When such type of things given in your question, like solid also and ions also, you have given the solid compound, like what they will form plus their ions also, then don't consider their solid compound, only consider their ions. Okay, now N minus A. Now the component is 1 2 3 3. There is ions, then minus 1 is equal to 2. Again I am saying, if solid and their ions both are given in your question, then don't consider their solid, then cut it, don't consider as a component. Then you have only 3 component here. Again Na plus Cl minus H2O, H plus Cl minus. Okay, this one is by mistake, it will be OH minus. Okay guys, Na plus Cl minus H2O, H plus OH minus. Again, if I'm talking about the solids like ions, then don't consider the solid of that ions, like you have checked in the previous questions. Now if like water dissociation is given in your question, like H2O will convert into the H plus and OH. All these 3 if mentioned in your question, like H2O, H plus and OH ions, this is not Cl minus, and H2O, H plus and OH ions only for in the case of water, then don't consider the ions of water. Okay, that is the totally different case what you have studied earlier. Like in previous it was like if an NH4Cl and NH4 plus and Cl minus both are given, then what you have don't consider NH4Cl. But here if water and their ions is given to you, then don't consider their ions. Okay, no, Na plus Cl minus H2O H plus and OH minus. Then if water dissociation is given, then don't consider their ions. Then what will be the formula? Now your component will be 1, 2 and 3 only. Don't consider them. 1, 2, 3, N is equal to 3 and neutral. Again ions is given, then E is equal to 1, then component will be 2. Again NaCl, Na plus Cl minus H2O OH minus H plus. Now see, now both can apply here what we have discussed in previous, like Na plus Cl minus can combine NaCl. I said when ions, when salt, there this is the salt, when salts ions and their salt is given, then don't consider their salt, you may consider ions. But if water and their ions is given, then don't consider their ions, you may consider their neutral molecule. Then you don't consider this one and this one. Then what you will be consider Na plus Cl minus and H2O. Then C is equal to N minus C. It means you have only 3 chemical species, 1, 2, 3, and their neutrality, like their ions, 3 minus 1 component will be 2. Again one question, CH3CO Na, CH3CO minus Na plus, CH3COOH, this is the acetic acid, H2O solid, H2O liquid, H2O gas, OH minus H plus. Again third condition, if in a given question if H2O solid, H2O liquid, H2O gas is given and they are not in equilibrium, guys, don't be confused. In the previous question what we have mentioned there, like H2O solid was equilibrium with H2O liquid, H2O liquid was the equilibrium with H2O gas, then you may consider. But here there is no any equilibrium, they are in the with the comma. Okay, then if it is mentioned there like H2O solid, H2O liquid, H2O gas, then don't consider their liquid and gaseous state, just consider only solid one. Okay, it means don't consider 3, we may consider only 1. So just cut solid, liquid and gas, you will really mention H2O liquid. Now here these are the ions, these are the solid of that ions, because they will combine to form CH3CONA, so you may cut this one. Again acid, there is no ions of this acid, so you may consider this one. Again H2O solid, H2O liquid and H2O gas, then what why I have told you, like you may cut this one, you may cut this one, you may only consider H2O solid. And again if H2O and their ions is given to you, then you may cut their ions too. Then what you have cut, H2O liquid, H2O solid and their ions and salt of that ions, then you have only 1, 2, 3 and 4. Okay, then 4, N is equal to 4 and your E, only neutral condition is there, then 4 minus 1 is equal to 3. Right, this is very important and several times they have asked for to determine the component of the given equation. Now 13, NH4Cl, NH4 plus, Cl minus, NH4OH, NH3, H2O liquid, H2O solid, H2O gas, H plus, OH minus. Again several things is given to you. You may also know when they is combined they will form this one, so this is the salt of this ions, so you may cut this one. Okay, now H2O liquid, H2O solid, H2O gas given, cut H2O solid, cut H2O liquid, cut their ions too. Then what you have, 1, 2, 3, 4, 5. Okay, so you have 5 and only neutral condition is there, like their ions, the 5 minus 1 is equal to 4. Okay guys, now this question, the last question which also mentioned several times asked to your examination, like NaCl KCl and water is 3 component system, and NaCl, KBr and water is 4 component system. Why? This question have asked several times in your exams. NaCl, KCl, water is 3 component, and NaCl, KBr and water is 4 component system. Why? Okay, now here if you dissociate these things into the ions like Na plus Cl minus ions, it will dissociate into this one. KCl will dissociate into K plus and Cl minus ions and H2O. Then this Cl and this Cl, because they are the common Cl, so you may consider only one Cl, either this one or this one, but you have to cut one because they are the common. Okay, like what you have did previous in H2O, like H2O solid, H2O liquid, H2O gas, then you have cut 2 and you have considered 1. Again same thing will be you will do with the Cl ion, because there is the 2 Cl ions, then you may cut 1. Both Cl ions similar, so only one chlorine you may consider. Then again now N minus C, count 1 2 3 and 4 and neutral condition, because you know neutral condition, like this will also form the KCl minus ion, and this will also form this NaCl minus ions, like NaCl or KCl, they can easily form with these Cls, and so 4 minus 1 neutral condition, your component will be 3. But where now in this case Na plus Cl minus ion, K plus Br minus ion, because this is the different anion. Okay, now H2O again 1 2 3 4 5 neutral condition, only 1. This will combine, they will combine, or they will combine, doesn't matter, they are the neutral condition. Then you will consider E is equal to 1, then your component will be 4. Okay guys, now I am going to summarize for this phase, component you can be determined by the N minus E condition. N is the number of chemical species, doesn't matter what, if same or different, this is the number of chemical species, you may count there. Okay, E is the equation. This E equation, if there is neutral condition and ions, then E will be the 1. Okay, like here C minus N minus C, N is equal to number of chemical species, N is the number of equation. If E is equal to 1 for the case of ions and their neutrality is equal to 1 for the case of equilibrium, E is equal to 1 if condition given when your product will be the gas and they have similar pressure. If it is mentioned in equation that they are not equilibrium, then you may consider, otherwise it will be considered as a 1. I have discussed it earlier. Okay, now 3 different things I have also mentioned here. If solid and their ions is given in your equation, then you may consider, don't consider their solid, you may consider only ions. If salt is given to you, okay, and if water and their ions is given to you, then don't consider their ions, only consider water. Okay, and if water in both 3 forms, like not both, like H2O solid, liquid and given gas is given to you, so don't consider these 2, only consider solids. Okay, so easily you can determine your component and phase of the system. Now the last topic is your degree of freedom, like F is equal to C minus P plus 2. I have told you how to determine phase, how to determine component. Now the last topic is how to determine phase of the system, degree of freedom. Okay, phase of the system you can easily determine. C component, you can easily calculate this component. Now I am going to explain this last topic, the degree of freedom. This degree of freedom, F is equal to C minus P plus 2. C is the component, I have already mentioned you. P is the phase, F is the degree of freedom. Now this is the formula, F is equal to C minus P plus 2. What is this 2? Like if you may draw anything in 2D. Okay, like when you explain anything on the paper or in board, you have 2D. The first is your temperature and second thing is your pressure. Either you may take x-axis temperature, pressure for any physical appearance, physical things when you are going to like explain. If like I am going to heat water, then what it will be, what will happen when we are going to heat water, then you may take temperature or pressure, or you may take temperature or concentration, like if I am increase the temperature, what will be the effect on the concentration? If I am increasing the pressure, what will be the effect on the temperature? It means these two tells about the coordinate of temperature and pressure, or coordinate of temperature and concentration, because we are explaining these things on 2D. Okay, 2D means on your paper, on your board. Okay, so this is simply a temperature or pressure coordinate, or temperature or concentration coordinate. Okay, now so how will you determine this F? Suppose this things is given to you. S2 is solid, then what will be the phase? Solid is one phase, component will be 1. What will be F? C minus P plus 2. 1 component is 1, phase is 1 plus 2. If it is 2, it means it is bivariant. Okay, you may call it bivariant. Okay, now S2O solid, S2O liquid. P is equal to 2 because they have different solid and liquid. C is equal to 1. You may calculate by n minus C is equal to n minus A. You may easily calculate this. Okay, like here number of species is 1, equilibrium is 1, then component will be the 1. What will be the F is equal to C minus P plus 2. 1 minus 2 plus 2 is equal to 1. It means it is known as univariant. Okay, now like the last one, S2 is equal to solid, S2 is liquid, S2 is gas, then phase will be 3. You have solid, liquid and gas, component will be 1. You may easily calculate n minus C is equal to 3 minus 2 is equal to 1 because there is 2 equilibrium. Okay, now C minus P plus 2, 1 minus 3 plus 3 is equal to 0. इसको बोलोगे आप, if it is 0 then it is known as invariant or unique point or triple point or non-variant. Okay, these 4 things you may call it if freedom is 0. Okay, like invariant, univariant, triple point, non-variant. This is very important, guide. It has asked several times what is triple point. Now if you consider these things, can you ever have think about this? S2O solid, S2O liquid and S2O gas will be in equilibrium at the same time, like they are solid. Ice, water and your water vapor will be on this at the same place. Yes, it will be, but this is in what do you mean by invariant or non-variant? Triple point means these 3 can coexist together. That's why they are known as triple point, because these 3 phase, solid, liquid, gas, can be coexist together at a given point. That's why there is 3 different phase. This is known as triple point. Okay, but when it will be together, it is very important, like there will be specific temperature, there will be specific pressure. If you alter any of the temperature or pressure, then this equilibrium will be disturbed. That's why this is known as invariant. Invariant means it depend both of these things. If you change any of these things, this will be change. So invariant, you miss this triple point, don't want any change in their temperature or pressure. Okay, now reduced phase rule. What is this reduced phase rule? F is equal to C minus P plus 2 is the phase rule. What I have told you earlier, this 2 is temperature and pressure, or temperature and concentration. It means it tells about the 2 variant. Like if what is reduced phase rule? F is equal to C minus P plus 1 or C minus P. It means you have reduced from 2 to 1 or 2 to 0. This is C minus P plus 1 or C minus P is known as reduced phase rule. It has also asked several times what is the phase rule, what is reduced phase rule. Phase rule is plus 2, reduced phase rule is plus 1 or simply C minus P. Like what I have told you, this is tells about the temperature or pressure, or temperature or concentration. If anything's mentioned in your equation, like if either temperature or pressure is given, or temperature or concentration, if any of these things is given to you, like example S2O solid, S2O liquid. Before that, when I have solved this example, it was nothing mentioned there like any temperature or pressure. But if anything is mentioned here like H2O solid and H2O liquid at 75 degrees Celsius, it means C minus P plus 2 is equal to F is equal to this formula. and it tells about the temperature and pressure, but one thing is already given to you, then it will be 1, because 1 is already given to you, then it will be simply 1. This is known as reduced phase rule. Now how to calculate the degree of freedom? Component will be 1, phase will be 2, F is equal to C minus P plus 1. Because one thing is already given to you, then you don't follow the formula plus 2. You have to follow the formula C minus P plus 1. So 1 minus 2 is equal plus 1 is equal to 0. Okay, now the last example is NH4Cl HCl plus NH3 at 75 degree and 2 atmospheric pressure. मतलब both two things are given to you. Then F is equal to C minus P plus 2, because both these things is given to you, temperature and pressure. Then don't consider this one, then you will calculate the degree of freedom by this formula guys only. Then C is equal to 2, P is equal to 2, F is equal to C minus P, 2 minus 2 is 0. Okay, now what is the application of this reduced phase rule? Application of reduced phase rule or phase rule is simply, phase rule is like if you are using stainless steel in your house, okay, because this stainless steel utensils is very common in households, in your kitchen. Like this is simply alloy. Okay, alloy, it contains iron, it contains nickel, it contains chromium. Okay, now what is these things? Iron give this to strength, what nickel give is to corrosion, make it to corrosion resistance, and chromium give stainless steel to the shine. That's why stainless steel like looks bit good. Okay, now can you mix these three in any quantity? Like I have taken 80% this, 10% this, 10% this. No, there will be some definite quantity you can add these things to make any alloy. There should be some specific quantity. This specific quantity can be determined by only and only phase rule. Okay, so this is the very good application of this to the formation of alloy. You may only use phase rule, what quantity you have to mix to make any alloy which will be good for you. Second thing, like you have fire alarm, you have water alarm. These things, it also work on the principle of phase rule. You have also safety plug in your motorbike and also in your electric board. Safety plug, it also work on this same principle, phase rule. And also soldering, like joining of two solid, like it's soldering is also work on this phase rule principle. These things we will discuss in the next class. This is all about your component, phase and degree of freedom guys, and how to calculate these things. I hope you will understand these things, and if you have any problem regarding the same, you may comment me, you may ask me after that. Okay, thank you very much guys.